Okay, hello everybody. Can everyone see my screen and hear me okay? Just a big thumbs up if everything looks good. Awesome. Thank you, Azra. Thank you, Carla. So my name is Marissa. I'm the graduate recruitment specialist for the Faculty of Science. I work in the Graduate Science Center. And me plus some other members of the university are going to talk to you about our quantum computing program today. So thank you so much for joining us. I will just let everyone know that we are recording this session. Our plan is to put it up on the website. So if you want to look over anything, it'll be up there for you to rewatch. So I'm going to quickly start with a land acknowledgement. So I would like to acknowledge the traditional territories of the people of the Treaty 7 region in southern Alberta, which includes the Blackfoot Confederacy, as well as the Tsuut'ina First Nation and the Stoney Nakoda. The city of Calgary is also home to Métis Nation of Alberta Region 3. So a couple of housekeeping items for today. Please just make sure that you're keeping your mics muted during the presentation. We will have a Q&A session at the very end where you can ask us questions. At that time, feel free to unmute if you'd like, type it in the chat. But for now, if everyone could just stay muted, that would be awesome. For this session, I'll go over it again during the Q&A part, but if you have very specific questions about your own circumstances, such as if your particular course meets your prerequisites or the status of your application, please just send me a quick email at prograd.science@ucalgary.ca. I'd be more than happy to go over it with you over there. And just a reminder, again, this session is being recorded. So I'm going to start us off today with a quick overview of the University of Calgary. So I'm actually a University of Calgary alumni. I graduated last winter, so I've been a graduate for about a year now, and now I work here. And I'm also repping the University of Calgary merch, the swag today. Just because it's really cold here. If you're not in Calgary right now, it looks like the picture on your right there. It is about -35 today. So that's great. It's not always like that. Sometimes it does look like the picture on the left. But anyway, the University of Calgary was founded in 1966. And just this year, well, I guess last year, 2022, it was ranked in the top 5 research universities in Canada. And we actually have 6 of our subject areas as well being ranked in the top 50 of their field around the world, according to the QS 2022 World University Subject Ratings. Excuse me. So we have about 33,000 students here at the University of Calgary, 6,000 of which are graduate students. My office specifically, the Graduate Science Center, who you will all be dealing with if you apply, if you get admitted, we handle just the science graduate students. So we're here to help you through the application process, when you get admitted, if you have any problems with that, as well as just your whole time in the program here. The Faculty of Science is actually the second biggest faculty at the University of Calgary, and we have 26 graduate opportunities. 6 of which are professional programs, which we'll be talking about today with quantum. We do have 2 other professional programs here, which is data science and information security and privacy. But today we're going to be talking about quantum. And last but not least, some research done by the university says that graduates from our university have about a 94% employment rate, which is pretty great. So I'm going to pass it over to Azra. She is one of our representatives from Quantum City, and she's going to give you a quick overview about why you should be doing quantum computing.
Thanks, Marissa. Hi, everyone. So as you know, I'm Azra, and I am the Manager of Training and Innovation for Quantum City. And I wanted to start this part of the information session off by talking about the national quantum strategy that was released this past January. And so now we're sitting at a very interesting point in time with quantum science, and where this next quantum revolution is expected to deliver is around major economic benefits. And according to a study that was commissioned by the NRC, which is the National Research Council of Canada, the quantum sector will become a $139 billion industry in Canada, with over more than 200 jobs and bringing in $42 billion in returns by 2045. So it is the place to be right now. The National Quantum Strategy aims to amplify Canada's strength in quantum research, grow Canadian quantum-ready technology, companies, and talent, and to solidify global leadership in quantum science and its commercialization. So the Government of Canada had announced that it is committing $360 million over the next 7 years to support the strategy implementation. And as a part of this plan, there are 3 key missions that the strategy has laid out to ensure that Canada is a leader in quantum innovation and leadership. So the first one is making Canada a world leader in continued development, deployment, and use of quantum computing hardware and software to the benefit of Canadian industry, governments, and citizens. The second is to ensure the privacy and cybersecurity of Canadians in a quantum-enabled world through the National Secure Quantum Communications Network and Post-Quantum Cryptography Initiative. And the third is to enable the Government of Canada and key industries to be developers and early adopters of the new quantum sensing technologies. So overall, this strategy shows that the government is there to support and to grow quantum science and technology. And it only means that there's going to be a demand in talent. And the University of Calgary is pleased to share this new program that we're launching in September of 2023. And I'll hand it over to Dr. Pierre Catapult to speak more about the program.
Hi, everybody. Yes, my name is Pierre Kenapol. I'm currently Associate Dean for Innovation and Strategic Partnerships in the Faculty of Science at the University of Calgary. And we are very excited about the new programs that we have in quantum computing. And as Azra mentioned, we're really sort of at the beginnings of a very sort of big shift, I think, on the technological front. And the comparison that I would make with respect to quantum computing and where quantum computing is that we're probably about 5 to 7 years behind AI. So if you think about machine learning and artificial intelligence, and you think back about 5 to 7 years ago, people were talking about machine learning as something that might be useful in the future. And people were talking about how it would be interesting to possibly get involved. And what you probably didn't see is behind the scenes, there was lots and lots of activity preparing the terrain. And just in the last 6 months, I think it's hard to go even a few hours without looking online and hearing about something related to either AI or machine learning. And quantum computing is sort of in that same realm. We're about a few years behind, but the whole point of the National Quantum Strategy is really to take those first steps and be in the lead when quantum computing really hits the big time. And from the standpoint of the professional programs, our goal here with our quantum computing professional programs, so there's a certificate of diploma, and hopefully very, very soon we will have the master's program that's upcoming with provincial approval. And the goal here is to basically provide that baseline training for professionals for what is quantum computing, how could you use it, and what does the future look like? And specifically, this program is not geared towards training scientists to develop new methods in quantum computing. It's really created for the people who want to use quantum computing in real life applications. And so the program itself is built, and I think Marissa will be talking a little bit about the nuts and bolts of the first few steps of the program. It's really based, in terms of its structure, it's based on our very successful data science and information security programs. Right now we have, I think we're close to 150 students in the combined programs right now in data science and in information security. And the goal here is to create that same type of program for quantum computing. And so maybe with that, I will pass it off back to Marissa to talk about the specifics of the program.
Awesome. Thank you so much, Pierre and Azra. So yes, I'm going to be doing the nitty gritty, the nuts and bolts. So we can quickly go over the program structure. So this diagram you see here is the full-time pathway for the program. So in the fall, you would begin with your graduate certificate. That certificate would last 4 months, and then you would move on to your graduate diploma, which would be in the winter of 2024, and it would last another 4 months. Like I said, this is a full-time pathway. Students are able to do a part-time pathway if they would like. It would just take a couple extra years. So let's get down into what kind of courses you'll be taking. So for the certificate, it is 4 courses. My understanding, and Pierre, jump in if I randomly start saying it wrong. My understanding is that you will be only taking 2 courses at a time throughout these 4 months. Perfect. I can keep going then. I got the head nod. So you will be taking what we call QUAC. I know it's a funny name. They want to change it. I think it's awesome. I think we should keep it. You will be doing QUAC 601 and then QUAC 605. So you'll be doing those 2 courses for 6 weeks. So September to October, mid-October, and you'll be doing those 2 courses at the same time. And then once you're finished those courses, you move on to your second 6 weeks where you'll be taking QUAC 603 and then 607. So I'm going to quickly go over the course descriptions, kind of what you'll be learning in each of these courses. So for QUAC 601, this is the essentials of quantum computing. So in this, you'll be learning about pure quantum states, unitary maps, projective measurements, quantum algorithms, quantum circuits, quantum resources, and quantum complexity. Alongside that, you will then be taking QUAC 605, where you will be looking at applications, including areas such as combinatorial optimization, linear equation solvers, factorization searches, simulation, chemistry, and machine learning. So you'll be taking, let's say QUAC 601 Monday, Wednesday. I believe we're going to be having evening courses for that. And then you'll be taking QUAC 605 Tuesday, Thursday. So you'd only be having courses 4 days of the week in the evening. They're typically about 2 hours each, and you'll be doing that for the first 6 weeks. The second 6 weeks, you're going to be looking at QUAC 603, which is application of quantum computing. In this one, you're going to be looking at quantum software stack, learning current quantum and hybrid software platforms, comparing with the non-quantum software as well. So you'll be doing that for 2 days of the week in the evening, and then you'll also be pairing that with QUAC 607, which is business of quantum computing. In this one, you're going to be looking at the fundamentals of how quantum computing is used in industry. Topics that are going to be covered include trends in adoption of quantum computing and how it may affect organizations and external stakeholders, future use cases, the structure and economics of platforms for quantum computing as well. So that's your certificate. It's 4 courses, and it is over the first 4 months. So it would be September to December. Next, I'm going to go over the diploma courses. So same structure. You're going to be doing the 4 courses over the 4 months, but you're going to be doing them in pairs. So for the first 6 weeks, you're going to be looking at QUAC 609, which looks at quantum software, and it's called number 2. So it's kind of the add-on to QUAC 603, which was software number 1. So in quantum software number 2, you're going to be looking at applying current quantum software and assessing utility for solving industry problems. Beside that, you're going to be taking QUAC 611, which is quantum hardware. And this looks at the principles of building quantum computers, universal quantum computers, quantum annealers, current commercial quantum computers, roadmaps for development of quantum computers. So lots about quantum computers, which you'd assume you would have in a quantum course. So after that, you're going to do that for the first 6 weeks. After that, you're going to move on to your second pair of courses. And these courses are going to be QUAC 613, which looks at practical quantum computing, and then QUAC 615, which looks at the business of quantum computing number 2, which will be the add-on to the business of quantum computing, which was 607 from the certificate. So 613 will look at noise, decoherence, loss, imperfect measurement, error mitigation, error correction, fault tolerance, gate benchmarking. And then 615 will, like I said, will be an add-on. So looking at how quantum can be used in the industry, such as quantum computing startups, business venturing, principles of entrepreneurship, and technology commercialization. So those are the 4 courses that you'll be taking in the diploma. So if there is an option that if you're like, hey, I just want to do the certificate courses, you can absolutely just apply for the certificate. And then let's say you've completed Business of Quantum Computing 1, and you're like, you know what, I really want to do the second one. I'm really interested in this. I want to complete the diploma. All you have to do is apply for a change of program, and we can scoot you on over and make sure you can finish the diploma as well and get both. Well, not both. You can get the diploma. So I'm going to quickly go over some FAQs. These may be questions you already have, so hopefully I answer some of them. After this, I will give it back to our Quantum City representatives to chat a bit about what Quantum City is. So we're going to start with the admission requirements. So you are not required to have an undergraduate degree in quantum technology, quantum computing. Like Pierre said, this is a program made not that you're solving problems of quantum, but how to bring quantum into the industry and how to use it in industrial problems and modern problems. So you do need a minimum grade point average of 3 on a 4-point scale or equivalent. If you're wondering if your GPA is equivalent, head on over to the Faculty of Graduate Studies. Their international student page goes over all of the equivalencies for GPA per country. You can look there and see what you need for that. And you will need a 4-year bachelor's degree. If you do have a graduate degree, that's amazing. That is great. Put it on your application. But we're not going to use your graduate degrees for the GPA calculation. So put it on there. We're just not going to use the grades from it. As well as the GPA requirement, we also need successful completion of the following courses at a post-secondary level with at least a B grade or equivalent. So these courses are a linear algebra course. I just have an example right there, Math 211, which is a University of Calgary course that we offer, as well as you need a computer programming course, which again, I have examples there. If you were wondering if your prerequisite courses count, if they're what we're looking for, you can definitely shoot me an email. I can give you the learning outcomes for both these courses, and you can see if the learning outcomes from the courses that you took kind of line up. If you, let's say you took a undergrad like me in biology, but quantum computing is like your new favorite thing, it's your passion, it's what you want to do, but you don't have a computer programming course. That is totally fine. Again, shoot me an email. We have lots of options of online courses that you can take to fulfill that prerequisite and get you in the program. And then, yeah, if your degree is from an institution that instructed in English, the ELP requirement is waived. If not, you will just have to send your test scores to gradapp@ucalgary.ca. Next, what documents do you need for your application? So you will need your unofficial transcripts. We will not ask for your official transcripts until you have been admitted into the program. So just an unofficial copy is fine for right now. You also need a proof of prerequisite document. So this one trips up students a lot because it's not something that we're used to. So this is a student-made document that is going to outline the learning outcomes, the course syllabus, the course description of the courses you want to use to fulfill that linear algebra course and that computer programming course. So you're just going to go and find the screenshot of the course you took. You're going to screenshot it, put it in a Word doc. You're going to find the screenshot of the computer programming course, put it in the same Word doc, turn it into a PDF and upload it. And that's just going to be our way of seeing if your learning outcomes match what we're looking for. And then last but not least, we would also ask you to upload a resume. Next, how long does this take? I did go over this pretty quickly, but I will just go over the little nitty-gritty parts. So for the graduate certificate, it does take those 4 months, September to December. If you were going to do a part-time enrollment, it will take at least 8 months. Typically, it would take about a year because we're only offering the courses for the certificate in the fall. So you'd take 2 courses and then you'd wait till the next fall and take the other 2 courses if that's something you're interested in. And then the maximum completion time is 3 years. For the graduate diploma, like I said, for full-time enrollment, it is 8 months. For part-time enrollment, it's at least 12 months, but again, you will have to finish your certificate courses before you move on to your diploma courses, so it will take probably a little bit more than 12 months, and then you have about 4 years to complete that program. Lastly, I touched on this pretty quick. Our next semester to apply, our first semester to apply, is brand new. This is our fall 2023 semester. The program deadline is May 1st for applications. And like I said, you can take this on a full-time or part-time basis. I believe that all the courses will be offered in the evening. So I know a question that students ask me a lot is, can you work full-time while doing evening classes? And that is completely up to your capacity. Lots of students in the data science program do it. So it's definitely doable, but it's up to you with what you're comfortable with. And then we will be teaching all courses in person, and I believe on the main campus in Calgary. Awesome. I'm going to pass it over to Carla, and she's going to give you a quick overview of Quantum City.
All right, thanks, Marissa. My name's Carla, and I'm the Manager of Communications and Public Engagement with Quantum City. And Quantum City is a newly created hub at the University of Calgary. It's in partnership with the Government of Alberta, the University of Calgary, of course, and a private partner named Emphasis. And Quantum City is all about fostering research breakthroughs in quantum innovations while also connecting quantum solutions to industry and vice versa. So Quantum City is essentially the connector of all things quantum to quantum research to Alberta's economy, which is pretty unique. I think we're one of few, if not the only one, that really focuses on that commercialization, which is what these programs focus on as well. And as a student, this means that Quantum City is ensuring that there's a marketplace for your quantum innovations right here in Calgary and Alberta and then beyond. So the next slide, please. Currently, Quantum City is working on designing and constructing a Q lab, a quantum lab, to provide an enhanced and dedicated space for quantum research. We're also working on an industry engagement strategy to strengthen the University of Calgary's quantum program and recognition. And with that comes business development, strategic planning, and that includes partnerships, which are the pathway to career opportunities when you finish these great programs that are being introduced at the university. And we're also working on an advancement strategy to ensure that there are pathways for both academia and business-oriented graduates at U Calgary's quantum programs. So that means beyond these programs, we're also there to support you and kind of pave the way, because it is such a new and upcoming area. And the next slide, please. I think there's some animations on this one, so you might have to do 2 or 3 clicks, please. Alongside the University of Calgary, Quantum City has tremendous research expertise and talent right here, and that's in quantum sensing, communications, and computing. And Quantum City has world-class researchers as well as industry connections to ensure quantum applications can be developed and then applied again to that commercialization. So that's Quantum City in a very small nutshell. Again, we're a fairly new hub here at the University of Calgary, and we're working hard to make that linkage right to industry so we can ensure that there are not only job opportunities, but applications in industry and business. So it's quite holistic, or as an ecosystem, as we like to say. So that's it in a nutshell.
Great. Thank you so much, Carla. I believe that is all that we have for you guys. We would love to hear your questions, any inquiries you have. Like I said, if you have very, very specific questions, it might be better to chat with me over email, but I would be happy to try to answer them here. But feel free to ask Azra and Carla as well, anything about Quantum City.
Hey, hi everyone. My name is Manjinder and I'm connecting from India right now. So I was actually looking for a postgrad course in quantum computing. I'm currently working as a backend software engineer. So I want to kickstart my career in this field. So I'm not exactly sure what will be the exact curriculum. As far as, I mean, when it comes to quantum physics or quantum computing, it seems like it's really mathematically intensive course or something like that. So I have one doubt on that. And another part of it is that I'll be applying as an international student. So I would like to know about the fee structure of the course. What would it be?
Yeah, so this program was built so that students didn't need like a whole undergraduate degree in math or a PhD in math or anything. If you have that one linear algebra course and you got a B in it and you feel solid about those kind of concepts, and it shouldn't be an issue. We create those requirements not to just have it so people can't get into the program. We have it so that that students are prepared and that they're ready to get into the program and get into the content right away. So I would say if you have that linear algebra degree, or not degree, sorry, that linear algebra course, it shouldn't be an issue. You can always take an extra one online just to kind of like revamp your knowledge, get more comfortable with it. That's what I always tell students. In terms of tuition, I don't have the numbers off the top of my head. I'm really sorry. I probably should have added a slide about that. But if you shoot me an email I'll put it in the chat, I can definitely give you the fee structure.
Sure. And one more question is that regarding the will I be eligible for the postgraduate work permit after this course, or what will be the scenario in that case if I take this course?
So I'm actually not allowed to speak on that. I just don't have the right training or certification. I will also put this in the chat for you, but I encourage you to reach out to International Student Services. They will have a better idea about postgraduate work permits, visas, all that kind of stuff that I can't talk about.
Okay, no worries. Thanks a lot.
You're welcome. If there is any other questions, feel free to type them in the chat, unmute. We do have lots of time left, but if there's anything else, you can also send me an email at prograd.science@ucalgary.ca, and I'd be happy to get back with you and chat about anything. Awesome. Well, thank you so much for joining us today. I hope this was informative. I hope this helped you learn a bit more about quantum as a whole, as well as our program and Quantum City. Yeah, and I'm excited to chat with you guys more. We will have more information sessions coming up if you want to hear more from more representatives. So have a great day, everybody. Thank you, Azra. Thank you, Carla.